Okay, welcome back scholars. How are you doing? Today we're going to be looking at associative and commutative properties. And these properties apply to multiplication and addition. They do not apply to subtraction or division. So the commutative property states that the order in which you add or multiply two numbers does not matter. The result will be the same. So it's a pretty straightforward principle. It's simply saying when you're adding two numbers, whether you start with, for example, if you're adding 12 plus 16, whether you start with the 12 and then add 16, or you start with the 16 and then add 12, the result should be the same. And we're going to test it to see if this is really the case. We're going to prove whether or not that's the case, right? It also applies for multiplication. 3 times 9 should give you the same as 9 times 3. You test it. Does it give you the same? What's 3 times 9? 27. And what's 9 times 3? 27, right? So we're going to prove it. We're going to test to see if the commutative property really applies. The associative property says the order in which we add or multiply 3 or more numbers does not matter. So if we have 3 numbers that we're adding or multiplying, it doesn't matter whether we add these two first and then that one, or these two first and then that one, or these two. If we move the 3 and put it here, and then add the 8, we're going to check to see if that applies, if that is really true, right? And we can also check to see if it applies to subtraction or division, right? So when we're done proving the laws for addition and multiplication, we can check to see if the law also applies to subtraction and division. So for example, is 20 take away 6 the same as 6 take away 20? Or is 40 divided by 10 the same as 10 divided by 40? Does it work both ways? We're going to see. So let's start with the commutative law, commutative property. It does not matter which one you start with. So 6 times 4 is 24. 4 times 6 is also 24. 8 plus 3, so this is for multiplication, this is for addition. 8 plus 3 give 11. 3 plus 8 also give 11. So let's see, we're going to add 146 plus 32, and we're going to see if we get the same answer as 32 plus 146. We're going to see if we start with the 146 and add the 32, it will get the same answer as if we start with the 32 and then add the 146. So let's see what we get here. 6 plus 2 is 8, 4 plus 3 is 7, and 1. So when we started with the 146 and then added the 32, we got 178. So let's see what we get here. We're starting with the 32 this time, and we're adding 146. 2 plus 6 is 8. 3 plus 4 is 7. Are those answers identical? Let me stand from afar and see. They look identical to me, 178, 178, right? So we have proven it for addition. The commutative law is proven for addition. Well, let's double check. Let's double check. Let's do another one. Maybe that was just a coincidence, right? sometimes coincidences happen. So let's do one more. So we're going to start with 825 and then add 230. And we're going to start with 230 and then add 825. And we're going to see if we get the identical answer, the same answer. 5 plus 0 is 5. 2 plus 3, 5. 8 plus 2, 10. So we got 1055. Let's see what we get here. 0 plus 5 is 5. 3 plus 2 is 5. 8 and 2 and 8 give 10. So, identical answers. See that? So this proves it for the commutative law. For addition, it does not matter which one you start with and then the other, or you start with the other and then that first one. You will get identical answers. Let's check it for multiplication. Let's see if it really applies. So we're going to multiply 12 times 3, and then we're going to multiply 3 times 12. So 3 2 6, 3 1s 3. Okay. 12 times 3 gives 36. Alright, 2 3s 6. 1 times 3 is 3. We get 36. So whether we started with the 12 and then multiplied by 3, or we started with the 3 and then multiplied by 12, we got 2 identical answers. So that's proven for that one, but we're going to double check. We're going to multiply 21 times 6 and then multiply 6 times 21. So 6 1 6, 6 2s 12. 1 times 6 is 6, 2 6s, sorry, 2 6s 12. 6 2. See, we got identical answers. So we have proven the commutative law for addition and subtraction and multiplication. Let's check it for subtraction. Suppose we had 46 take away 26. 46 take away 26, we would get 20. Right? Suppose we had 26 take away 46. 26 take away 46. Immediately you look and you see that the bigger number would be at the bottom. So we are unable to do that operation at this level at least. When you go higher up, you would see that you would actually get a negative number, which would be different from the positive number. So it proves that they do not give the same answer, right? You don't have to concern yourself with negative numbers at your level, but all you need to know is that the answers would not be the same. Let's try it for division. So suppose we are dividing 25 by 5. Okay? 25 divided by 5, the answer would be 5. 5 goes into 25 5 times. Suppose we divided 5 by 25. What would that answer be? We'd actually get a fraction, because 5 goes into 5 one time, 5 into 25, 5. We would end up with 1/5, which is a fraction, a completely different number from 5. So we have proven that the commutative law does not apply for subtraction or division. It only applies for addition and multiplication. If you're adding or multiplying two numbers, it does not matter which one you start with and which one you end with. If you switch them around, you will get the same result once you do your adding up properly. So let's look at the associative property. It's very similar to the commutative property. The associative property states that the order in which we add or multiply three or more numbers does not matter. The result will be the same. So what this means is, if you are adding or multiplying three or more numbers, it doesn't matter which two you start adding first. So the bracket tells us which two we would start with. So if we have 6 plus 8 plus 3, if we add the 8 and the 3 first, and then add the 6, or if we add the 6 and the 8 first, and then add the 3, or if we add the 6 and the 3 first, and then add the 8, we should get the same answer. Let's check it though. Let's check. As scholars, as mathematicians, we love to check. Mathematicians get great pleasure in double checking. So we are going to see if we add, so for this one we'll add the 3 and the 8 first, and then the 6. So 3 plus 8, 11 plus 6 would give 17. Okay? 3 and 8, 11 plus 6, 17. 8 and 3, 11 plus 6, 17. 8 and 6, 14 plus 3 also gives 17. So it does not matter which two you add first and then the other one, you're going to end up with the same answer for addition. For addition. Let's check it to see if it works for multiplication. So 2 times 4 times 5. Suppose we work the 2 times 4 first. 2 times 4 give 8, and then we multiply by 5, we get 40. Suppose we multiply the 4 and the 5 first. Remember, the bracket tells us which one would work first. 4 5 20 times 2 also gives 40. Suppose we worked the 2 times 5 first. 2 5s are 10 times 4 also gives 40. See that? Alright, now we're going to check if it works for these three numbers. 21 times 6 times 4. Suppose we rearrange it and multiply the 21 times 4 first, times 6. So we're going to multiply the 21 times 6 and then multiply that answer by 4. And we're going to multiply the 21 times 4 and then multiply that answer by 6. So the associative law is telling us we should get the same answer. Are we going to get the same answer? So 21 times 6, 6 1 6, 6 2 is 12. So now we're going to multiply that number times 4. 4 6 is 24, 4 2 is 8 and 2 10, 4 1 is 4 and 1 5. Okay, so this is our final answer. That's the product. Let us check if when we multiply 21 times 4 and then multiply that answer by 6, are we going to get this same answer? Do you think we're going to get that answer? Let's see. 4 1 is 4, 4 2 is 8, and now we're going to multiply the 84 by 6. 6 4 is 24, 6, 8, 48 plus 2, 50. So, we did end up with the same answer, 504. Whether we multiply the 21 by the 6 first and then multiply that answer by 4, or we multiply the 21 by the 4 first and then multiply that answer by 6. Okay? Now I think we should check to see, suppose we had multiplied the 4 times 6 first and then multiply that answer by 21. Let's check that. So 4 times 6 would give 24. So if we multiply that answer by 21, 1 times 4 is 4, 1 times 2 is 2, 2, 4 is 8, 2, 2 is 4, 4 and 0 is 4, that is 10. So we do still get 504. See that? If we rearrange them and we multiply the 4 and the 6 first, we would get 24. And if we multiply that 24 by the 21, we still ended up with 504. So the associative law does apply to multiplication, it applies to addition. Okay? And we proved it. We also proved that these properties do not apply to subtraction or division. If you subtract one number from the other, you will not get the same answer if you reverse it. If you divide one number by the other, you will not get the same answer if you reverse it. Okay? So, unless they are identical, no, unless it's 4 divided by 4, or so on. So, to recap, commutative law, commutative property states, for addition and multiplication, it does not matter which one you start adding or multiplying. It does not matter, you will get the same answer. For the associative property, for 3 or more terms, if we're adding or multiplying, the order in which we start adding or multiplying, whether we group these two first, or these two first, or these two first, and then add or multiply the other one, whether it's 3 of them, 4 of them, 6 of them, once it's addition and multiplication, it does not matter, you will end up with the same answer. And I want you to go and check. Gather up some numbers for the commutative, just use 2. For the associative, 3 or more. Try adding them, switch them around, multiply them, switch them around. Do these 2 first, then the other, these 2 first, then the other. Check for yourself and see if you end up with the same answer. Okay? So, if you have benefited from this video, please share the video so that other students can benefit as well. Share it to your friends, share it to your neighbors, share it to your classmates. Also, please leave a comment to say, "Thank you, Miss. Thank you for teaching me about the associative and commutative law." I would appreciate your feedback. If there is any topic you would like me to do a video on, please let me know and I will certainly do it. If I have done that video before, I'll refer you to it. Please subscribe if you have not subscribed as yet. And join me next time where we look at another topic as we progress through our mathematics course. So scholars, take care. I'll see you next time.